Good morning, good evening, pardon me, ladies and gentlemen. Terrific to have you here with us. We are the 26th of November, the day after my birthday, which was a wonderful weekend with the family. And we have a very special guest with us this evening for our webinar series, that being Kirsten Zickfeld of the University, Simon Fraser University in British Columbia. A lead author of the IPCC's 1.5 Special Report on 1.5 degrees of warming. We also have with us Eddie Perez of the Climate Action Network Canada, international policy analyst, and Danielle Horan-Greenford of the Damon Matthews Climate Lab here in Montreal. My name is Matthew Chapman. I'm the campaign coordinator for Climate Reality Canada, and very, very happy to be convening this webinar this evening. A brief piece on Madam Zickfeld. Pardon me. There we are. Professor Zickfeld is an associate professor in the geography department at Simon Fraser University, which she joined in 2010. She holds a PhD in physics in 2004 from the University of Potsdam in Germany. Her primary research interests are in the long-term effects of human activities on climate, and her current research explores the reversibility of human-induced climate change, carbon budgets consistent with climate targets, and climate carbon cycle feedbacks. She served as the lead author of the recently released IPCC Special Report on global warming of 1.5 degrees, as I mentioned, and is a lead author of IPCC's Sixth Assessment Report, which will be due, depending on which section of the report, between, I believe, 2020 and 2023. Is that right, Kirsten? It sounds about right, but you're muted, so hold on. There you go.
Yeah, so yeah, between 2021 and 2023, that's correct.
Okay, wonderful. Terrific. So with that, I will briefly present kind of the context of the campaign that this webinar falls in. And many of you posed questions leading up to the webinar about what's the plan of action? And that's something that scientists can certainly suggest, but cannot necessarily, make any definitive claims around. Their role is to study the science and report on the science as impartially and dispassionately as possible, such that their research is in fact as accurate as can be. The what to do about their research is very much a political and civil society question. So that's where Climate Reality Canada comes in, and we're very happy to base our campaigns and our initiatives on the research that is done at the international level. So as many of you may be aware, Climate Reality International does three of these trainings a year. This was from about a year ago in Pittsburgh. The objective being to train individuals to take the science and communicate it to their communities. What we find increasingly is that people listen to people that they know and care about and like. They don't necessarily listen to reports that are written, from across the world, unless they have a personal attachment to that, or unless they're a phenomenally rational person and they decide that they're going to put changes in their lifestyle into practice that are based on strictly research. Frequently it's a personal connection that you have with somebody, or there's a culture kind of moving you towards that. And that's what Climate Reality is about: building a culture in communities by training leaders like these ones, the Canadian delegation in 2017 to Pittsburgh. The campaign that we're currently really working hard on is at the municipal level in Canada, focusing on municipal leaders, empowering mayors, empowering city councillors to take action ambitiously on climate. And that multiplies the number of people engaged and the number of people responsibilized or accountable for this action by thousands. If you think of one state leader, the Prime Minister of Canada, for example, is one person, plus his cabinet might be 10 people, 15 or 20 odd people. But when you start saying it's not just the federal government's responsibility, it's not just the provincial government's responsibility, but it's every municipality across the country's responsibility, and every individual as well. But what we're trying to do is encourage and support municipal officials in the pursuit of carbon neutral targets at their municipal level. And that falls within the research that is well established and that culminated most recently in March at the city's IPCC conference in Edmonton, Alberta. So that's the strategic focus of Climate Reality's initiatives. So very quickly, this is where we're headed, or this is our target in Canada, and this is where we're currently headed according to government projections. So we're a long way off from being on track for our 2030 targets. And with that in mind, very quickly, the level of municipal engagement in Canada is underwhelming. And if we want to reach people in their communities with their friends and family and business leaders and religious leaders and professional associations, we need to do so through at the community level. And that's why we're inviting everybody, if you haven't already, to visit climatehub.ca. We need to coordinate our efforts much better in order to take action municipally, but of course also provincially and federally. But much of those kind of larger, broader policy goals will be served very well by building community around solutions, so that people don't think of it as pie in the sky ideological numbers, but rather, how is this impacting my daily life? And one of the things that we're in the middle of executing right now is a benchmarking initiative to demonstrate that in our daily lives, we can significantly improve. I'm going to skip through a couple of these to move quicker, but we can significantly improve our quality of life. And these are the indicators which we are tracking. Pardon me, I didn't realize there were quite so many slides here. There we go. So we're tracking things, and these indicators will be released on the 11th of December. So cost savings, safe streets, affordable housing, public transportation, cycling infrastructure, green jobs, air quality, things that any rational family or person would want to see improved in their community. So that's what we're focused on. With that, I will now cede the floor to Kirsten, and we'll invite her to give her presentation on the impacts of 1.5 compared to 2 degrees, and some of the tipping points that we could be crossing if we're not careful.
Okay, good. So I'll share my slides now. Okay, good. So what I will do is focus on some of the key findings of the report. So this is a fairly thick report with a lot of detail, but I'll focus on some of the top lines here. So first of all, why a report on 1.5 degrees? And as probably most of you are aware, 1.5 is a climate target, which is included in the Paris Agreement, where nations committed to holding the increase in the global average temperature to well below 2 degrees above pre-industrial, but also to pursue efforts to limit the temperature increase to 1.5 above pre-industrial. And so before this report, there was a lot of science out there on the 2 degree target, because that's a number that has been around for a while. But actually, we knew very little about 1.5. So some of the questions that this report attempted to answer is, first of all, where are we with regard to 1.5? So in terms of global mean temperature, what are the benefits of when we're limiting warming to 1.5? So the necessary actions will certainly come at the cost. So we need to understand what we gain by limiting warming to 1.5 as opposed, let's say, to 2 degrees or even some higher target. And then the third question is, how do we get there? So what are some of the systems transformations that are required to limit warming to 1.5? And I've structured my presentation along those 3 lines, or these 3 questions. So the first one was, where are we now relative to 1.5 degrees? And this figure here shows on the vertical the global warming relative to what we used as the pre-industrial period, which we here took to be the second half of the 20th century. And then here on the horizontal, you have time. And this very wiggly gray curve, this is the observed monthly mean temperature data. And then the orange line that you see here, this is the warming that is caused by human activity activity. So we call this the human attributable warming. And if you go to 2017 and you read along the vertical axis, then you see that we come in at about 1 degree of global warming. So what we concluded here is that in 2017, the human or the anthropogenic warming was around 1.5 degrees Celsius relative to this pre-industrial period. Also, if you go from 2017 into the future, and now I'm looking at this dashed orange line here, what this shows is that at the current warming rate, which is roughly 0.0 degrees Celsius per decade, the global warming of, or 1.5 degrees global warming will be reached around 2040. So in 22 years from now, with a little bit of uncertainty, because sort of there is so there are some measurement errors, there are some methodological issues which put a little bit of an error on the present day global warming, and also onto the extrapolation into the future. But the best estimate here is that if we continue along the current warming trajectory, then we'll hit 1.5 in about 22 years. What is very important to realize is that when we talk about these global mean temperature limits, so 1.5 degrees, 2 degrees, these are global mean values. But the warming in specific regions and specific seasons may actually quite different. So if you look at the larger world map on the top, and then the color bar on the right, you see that the coloring goes from light orange to actually dark orange, and then red and purple as we move north. And so this is for the decade 2006 to 2015, again relative to pre-industrial. So what this indicates that even though the global mean has warmed by 1 degree, many regions have already warmed much more than that. And if we're looking at the Arctic, so we're in excess of 2 degrees, and in some regions, even in excess of 3 degrees. So, so especially regions on land in the Northern Hemisphere have already warmed much more than 1 degree. And for Canada, so generally the rule of thumb is that Canada warms as twice as much as the global average. So if we're looking at Canada as a whole, it's so we see a human induced warming of about 2 degrees relative to pre-industrial. And then if you look at the lower panel, so the one on the left is for winter, the one on the right is for summer. There's a lot of purple in the Arctic and northern North America and also Siberia. And what this indicates is that a lot of the warming has been happening in the winter as opposed to the summer. Okay, so here the take-home message is that when we're talking about 1.5 degrees, we're not talking about 1.5 degrees everywhere, but we might be talking about actually 5 degrees warming in the Arctic and 3 degrees warming in Canada. So, what sort of what are some of the impacts that might happen at 1.5, and how do they compare to some of the impacts at 2 degrees Celsius? So as I said, we're currently at 1 degree Celsius warming. And as you all know, this warming has already caused a number of impacts with very serious consequences for ecosystems, for human livelihood, for well-being, and events that we can clearly attribute to human activities is, for example, an increase in the frequency of heat waves, an increase in the frequency and intensity of heavy rainfall, an increase in the intensity and drought and intensity and frequency of drought in several regions. And here just a number of just a couple of quick examples. So this is flooding from Hurricane Harvey in Houston in August 2017. And here the science indicates that this event was a number of times more likely because of climate change than then had the planet not warmed as much as it did. There's also an imprint of human activities on the drought in California. So this is a picture from 2014. And there's also some research that indicates that human activities have increased the likelihood of extreme fire seasons, such as the one in British Columbia in 2017 and also in 2018. So what this indicates is that, so we're at 1 degree and we're already seeing a number of impacts. And as the temperature keeps increasing, these impacts will become worse. So, so the conclusion here is that 1.5 is by no means a piece of cake, but we'll actually see a worsening of the impacts that we're already observing. So how do the impacts at 1.5 compare to something which is even higher, let's say 2 degrees, which is sort of the less ambitious target that's included in the Paris Agreement. And so limiting warming, so what the report makes very clear is that limiting warming to 1.5 as opposed to 2 or even some higher targets actually has very clear benefits. So one of those is less extreme weather, including extreme heat and rainfall. Less sea level, so by 2100 we'll see 10 centimeters lower sea level compared to 2 degrees. So this number may be difficult to put into context, but what it means in terms of a number affected by rising seas, it would expose 10 million fewer people along the coast to sea level rise. Also, what I should mention here that even if we limit warming to 1.5 degrees, it will not stop sea level rise. So sea level rise is very hard to stop because of the heat that's already absorbed by the ocean, which leads to expansion of seawater, and so the sea level rising. And so even though even if we manage to limit warming to a relatively low target, we will see sea level rising for a very long time. Even though the lower the target we aim for, the less the sea level will be, but still it will be it will continue to rise for a long time. Also, in terms of the benefits of limiting warming to 1.5 as opposed to 2, there is a substantially lower chance of an ice-free Arctic Ocean in the summer. So at 2 degrees, we're looking at sea ice-free Arctic in 1 time per decade, whereas at 1.5 degrees, it becomes relatively likely. So here we're talking about frequency of perhaps one in a century. And sea ice in the Arctic has a number of very important functions, both for ecosystems, for indigenous communities, but also for climate itself. And in fact, there are there are indications that sea level rise or loss of sea ice in the Arctic might driving some of the extreme weather that we're seeing around the planet. Also, limiting warming to 1.5 may give us a greater chance of saving some coral reefs. So at 2 degrees, we're quite likely to lose them all around the planet. Whereas at 1.5 degrees, there's a chance that 10 to 30% of coral reefs could be saved. And so in terms of population, so the global population that's exposed to water stress would be 50% less under a 1.5 scenario than a 2 degree scenario. So the report looked at the number of impacts, and this is just sort of a small selection. But one of the conclusions from the report is that the risks of at 2 degrees greater or much greater than at 1.5 degrees. And so there are clear benefits in limiting warming to 1.5. So now coming to the third part, which is about how we get to 1.5. And one instrument that's used in the report to analyze what needs to be done to limit warming to 1.5 is that of a pathway. So an emission pathway is a trajectory over time, which shows how emissions of carbon dioxide or other greenhouse gases, things like methane or nitrous oxide, change over time. And so in this figure here that is shown on the left, so on the vertical axis, these are billion metric tons of carbon dioxide per year. So these are global total net carbon dioxide emissions, and again, as a function of time. And first, I would like to focus on the blue envelope. So this blue envelope that you see in the figure, this is the range of these emission pathways that limit warming to 1.5 at the end of the century with no or limited overshoot. So what overshoot means is exceeding 1.5 for a limited period of time. And so there are some characteristics of these pathways that emerge from this figure. So first of all, if you look at the time axis and the maximum emissions, you'll see that emission will have to come down pretty soon. So in all emission pathways, emissions start to decline globally around 2020 or shortly thereafter. Then what you see is a very sharp decline after 2020. And then as we approach the middle of the century, so 2040 to 2060, then you see that the majority of emission pathways reach net zero by mid-century. And then in the second half of this century, they drop below zero. So the solid line here in the middle of the graph, that's the zero line. And so you see that many of these blue pathways, they drop below zero. So so what this means is that these emission pathways that are consistent with limiting warming to 1.5, and for the most part, require removing carbon dioxide from the atmosphere. So there are different ways of doing this. It can be done by planting trees or by using bioenergy, for example, and instead of letting the exhaust escape into the atmosphere, we could capture it and store it underground, and that would effectively remove carbon dioxide from the atmosphere. However, as I will say in a moment, many of these technologies that remove CO2 from the atmosphere are very speculative. And so today we don't know if we can upscale them or if we can use them at the scale that would be required to remove large amounts of carbon dioxide from the atmosphere. Okay, so sort of any path that takes us to 1.5 needs to reduce emissions globally in the next few years, very steep emission reductions over the next few centuries, in fact, reaching about 50% reductions relative to 2010 by 2030, and then being carbon neutral around mid-century. Also, something I wanted to point out here, if you look at this gray envelope, so these are emission pathways that have a higher overshoot. So they exceed 1.5 by a greater amount. And what you can see is that the emission reductions start later. And then at the end of the century, they dip more into the negative. So, emissions need to become more net negative than in the case of the blue scenario. So what this indicates is that if we want to limit warming to 1.5 and we delay our emission reductions, then we need to increasingly bet on these carbon dioxide removal technologies in the second half of the century. So what I just showed is for carbon dioxide. So the panel here on the right shows these emission pathways for other greenhouse gases. And what you can see is that they also need to come down considerably, but they do not reach zero. And in fact, if you look at the lower panel, which is the nitrous oxide emissions, these stay above zero. And the reason is that most of them are related to food production, and they're actually very difficult to eliminate. And this is also one of the reasons that in order to limit warming to 1.5, we need negative emission reductions to offset some of the emissions that are difficult to eliminate. So sort of a couple of summary points here. So to limit warming to 1.5, CO2 emissions need to decrease about 45% by 2030, measured from 2010 level. They need to reach net zero around mid-century, and emissions of other greenhouse gases such as methane, nitrous oxide would also need to be reduced. So how do we achieve these these enormous reductions? So first of all, limiting warming to 1.5 would require changes on an unprecedented scale. So if we look historically, then we would need more than what even at an individual country level has been realized in the past. We would need deep emission cuts in all sectors. So this means that transportation, industry, buildings, the agricultural sector. So we would need deep emission cuts in all sectors. So there's no sector that can get a free ride here. But really, emission reductions need to happen everywhere. Also, there is no silver bullet, so we need the range of technologies to achieve this. And this includes energy efficiency, it includes renewable energy, to a certain extent, also carbon capture with sequestration. It also, so these are sort of the system level changes that need to happen, but we also need changes in behaviors. So at an sort of individual and societal level. And in order to make all of this happen, we also need an increased investment in low carbon options, which means sort of moving investments away from fossil fuels and into these low carbon options. And as I showed in the figure, most, or I would say almost all pathways that are consistent with limiting warming to 1.5 also need some form of removal of carbon dioxide from out of the atmosphere. So what I would like to do next is for one specific scenario, look at some of the implications in terms of energy that are required. So in the summary for policymakers, so this is what SPM means of the IPCC, we looked at 4 different emission pathways. So here they're labeled P1 to P4, and these graphs here, they break down the contributions from different emissions. So gray, these are carbon dioxide emissions from fossil fuel industry. Brown means emissions from afforestation, forestry, and other land use. And then here, yellow, this is bioenergy with carbon capture and sequestration. So this is what I've talked about earlier. So the use of bioenergy and then capturing the carbon dioxide that's produced and either storing it in geologic formation or making it into something that can be used. And so these pathways, as you move from left to right, so they become sort of less and less ambitious in the short term, and you see the sort of the area of yellow increasing as you move towards the right. So so this means increased reliance on these carbon dioxide removal technologies like BECCS. So what I would like to do is sort of look a little bit more closely at this P1 scenario, which is the one that sort of does not rely on bioenergy with carbon capture and sequestration. And so this is a scenario with very strong innovations in energy efficiency. So if we become more efficient in our use of energy, then we need to produce less energy. And so this sort of a pathway with huge gains in energy efficiency actually allows us to decarbonize a large proportion of our energy system. And yeah, so as I said, I'll focus on this scenario here, and I'd like to sort of to point out some characteristics of this scenario. So what is highlighted here in the blue box. So this is in this specific scenario, the sort of the energy sort of use that comes from coal, oil, and natural gas. And here the bottom line is that by 2050, so by mid-centuries, coal will need to phase out, oil will need to decrease by 87% relative to present day, and the gas will also need to decrease significantly, so down 74% from present day. So what this indicates very, very clearly, which is also interesting in terms of sort of the energy and conversation that we're having here in Canada around natural gas, around pipelines, is that these emission pathways, they do not allow for growth in the fossil fuel sector. So quite the opposite, they require massive reductions in the energy that comes from fossil fuels, and they require upscaling of renewables. So this is highlighted in the second box here. So by 2050, we need an 800% increase in renewable energy by mid-century. So and this is sort of this is globally. So so let me conclude some of the key findings from this report. So climate change is already affecting people, ecosystems, and livelihoods. Limiting warming to 1.5, according to this report, is not impossible. So I think that was actually sort of some good news that came out of this report. So there still is a path to 1.5, but it is extremely challenging. And also what the report emphasizes is the importance of the near term. So the next 10 years are really crucial in determining whether this is something we can achieve or not. And as I also showed, is that there are clear benefits to keeping warming to below 1.5 as opposed to 2 degrees. And what is important here in terms of risks of global warming, really every bit of warming matters. So every let's say 0.1 degree of warming that we can avoid makes a difference in terms of the risks of climate change. And something I didn't talk about, but the report focuses on quite a bit, is that limiting warming to 1.5 can go hand in hand with reducing poverty and also achieving the sustainable development goals. And yeah, finally, to finish, just a couple of reflections of what this all means for Canada. So first of all, so Matthew showed this graph at the beginning with Canada's emission reduction target, so 30% by 2030. So this is by no means consistent with what's required to limit warming to 1.5. So, so I said globally we need 45%, but actually we need an even greater commitment from industrialized nations, because historically they've emitted more, and they also have a much higher per capita emissions. So when we're talking about industrialized nations, we talk something which is at least 50%, but in fact is closer to 60 or 70%. So this is enormous, and it's it's not reflected in the current level of ambition of the federal government. And the second point I would like to make here is that there is no room for fossil fuel development and emission pathways that are consistent with limiting warming to 1.5. And if we want to reduce the reliance on these negative emission technologies or carbon dioxide removal technologies, then oil, gas, they need, then sort of oil and coal need to be phased out by mid-century, and the use of natural gas needs to come down considerably. So this is all I wanted to say. So I'm happy to take questions.
Terrific. Thank you very much, Kirsten. As you can see, the email address is there for our panel, our viewers to make use of. In just a moment, I'll invite Eddie Perez of the Climate Action Network to moderate questions. I would just like to remind you all that questions can be submitted via the Q&A feature. There have been about 30 questions already submitted via the registration form. So Eddie will be pulling questions from that form, from the Q&A feature, and from the chat box. So there are three ways that you can engage with questions. And I would also mention that we do have, what do we have, about 22 minutes. So Kirsten, and I would also like to invite just in a moment Daniel Horn-Greenford to introduce himself briefly. They will have time to respond to questions, and it's important to note that that the responses to their questions will be available in a Google spreadsheet afterwards. So don't worry if you didn't catch everything. We're going to try to make sure that every question gets answered in that written format later on. And many of the questions, unsurprisingly, are directed at Kirsten's expertise in tipping points, and how close to the edge are we, and what if, and perhaps she'll be able to clarify some of those pieces for us as well. But first, I'd like to introduce Mr. Eddie Perez. I had his bio in front of me a moment ago, and it's no longer there, so I'll just go from memory. Eddie's a longtime collaborator. He did a tour of the Americas on public transportation, speaking to thousands of people about climate change about 6 years ago, or five or 6 years ago. And he's formerly a colleague of mine at Climate Reality, now at the Climate Action Network Canada, and the coordinator of the International Caucus of the Climate Action Network Canada. So with that, I will leave it in his hands, and maybe also just briefly ask Daniel to jump on and say hello before we jump into the questions.
Great. Hi, everyone. Thanks for having me as well on the panel. I'm a PhD student with David Matthews at Concordia University here in Montreal, and my work at the moment is on climate policy in Canada, whether it's equitable, and how to stack it up against wider notions of equity in international cooperation. How do we reconcile the difference between what we deem as feasible and what we see as equitable? And also I work on climate impacts of fossil fuel infrastructure and other input-output economic stuff, looking at impacts of the economy in different ways. Thanks.
Matthew, do you want me to jump in?
Please, Eddie.
All right, thank you. So first of all, thank you to Kirsten for this amazing presentation. Trying to resume an 800 pages report into 30 minutes discussion is extremely difficult. And I think, Kirsten, you've done an amazing job to speaking about the most important bits of that amazing report that was done by the IPCC. So I think before we go into the very detailed technical questions, I actually have a personal question to you. How, and I know that you work a lot on, you know, the anthropogenic aspect of climate change. The question of transitioning to a net zero carbon future seems sometimes very difficult. You know, it's hard, it's fast. How you as a scientist how do you try to come to an understanding of the human side of transitioning towards a net zero future as an expert, but also as a human person? Based on this report that calls us to act in 12 years, transitioning seems very difficult and very fast. What is your perspective on it? What is the human side of transitioning?
Yeah, so perhaps sort of as a preface to this, this report has often been depicted as sort of doom and gloom and sort of very, very dire. And I would say sort of in terms of the impact, that certainly is. But I think sort of the fact that we have this window of opportunity, which is still open, I think this is actually very good news. And when we set out to write the report, I don't think that it was clear, because as I said at the beginning, a lot of the science did not exist. And so if you look at the fifth assessment report of the IPCC, for example, you look at carbon budgets, which is the amount of carbon that we still have available before we hit 1.5. It was it was much more pessimistic. So I would say sort of the fact that we do have sort of this window of opportunity, and that we still have some pathways that lead us there. I think that's actually very, very good news. And so what the report also indicates is that we do have the technological means to do this transition. So we know how to do it. We have the renewable technology. We have sort of the battery technology, so that we know what innovations are required in the grid to upscale renewables to very large scale. So I think sort of technologically, the know-how is actually there. And I think what is missing is the political will. So that's, to me, the conclusion out of this report. So this is why it's so difficult to answer the question: is 1.5 feasible? Because let's say if we're talking technologically and then yes, we do have the technological means. But is it really feasible? I would say, well, we don't we don't know, because it depends very much on sort of where our political leaders are willing to take us. So
yeah, and maybe just to build on that point of political leadership, I think that is a very important point. And I think the IPCC in the summary of policymaker, the fourth section of the policy, the summary of policymaker, has a new section actually for IPCC report, which is building on SDGs and sustainable development goals and national determined contributions, which is more into the prescriptive side of policy making within the UN. And so I'm wondering, I think some folks have actually asked this question, and building on political willingness, because I think one of the things that comes out of this report is how to build policies using the 1.5 baseline scenario. What are these reasons of concern, and how can working towards holding temperature to 1.5 benefit sustainable development goals?
Yeah, I mean, that's a very, I would say, sort of very complex question, because there are many sustainable development goals, and many have either have synergies with mitigations, but some also have some trade-offs. So one example would be reducing the risk of hunger. So if we increase the amount of land which is devoted to bioenergy plantations, for example, then there's a clear conflict between bioenergy production and food production. So that's a clear sort of trade-off between either sort of renewable energy from biomass versus producing food. So this could be sort of one area where sort of achieving 1.5 while at the same time sort of eradicating sort of hunger and poverty could be at odds. So any strategy that limits warming to 1.5 has to be sort of attentive to this potential conflict. And sort of other examples, another sustainable development goal is sort of access to clean and sustainable energy. And this is one where sort of where the synergies between emission reductions and sustainable development are quite high. So I would say so there are some there are some areas where the two are not always easy to reconcile, but sort of overall the report concluded that mostly because of the severe impact of climate change in the future on anything from availability of clean water to availability of food, sort of would have very severe consequences. So avoiding that is in line with fighting hunger and promoting sustainable development.
Yeah, and so that brings me to another point, which are the reasons for concern. And there is a lot of, I think, discussion about tipping points. What are the tipping points we're going to cross first? We can think about coral reefs. We can think about water scarcity, aquifers. We can you give us a bit of a view of these tipping points?
Yeah.
Which ones are those that are coming first? And the difference may be, and maybe Daniel could come up here after because of his experience on oceans, on the ocean, I would say. But what are these tipping points that we may be able to cross first, and how soon?
Yeah, so I was trying to I have I have a sort of a slide that I'm trying to find out. So I think so please ignore. Here you go. Okay. Yeah. So I think sort of the first point is to sort of define a little bit what we mean by tipping point. I think sort of things that you define, things like sort of coral reef, sort of coral reefs, water scarcity. I would say sort of from a systems perspective, these are not necessarily tipping points. So they may be critical thresholds. So sort of as tipping point, let's define these sort of these system levels sort of point, which would trigger a series of feedbacks that could sort of affect the climate system worldwide. Not to say that these critical thresholds are not important. So so what I wanted to show is so is the slide, does it show or? Okay, here you go. So is the slide showing or? Yeah,
it is showing. Yeah.
Okay, good. Yeah, it's okay, good. It doesn't matter because it went back to the one, it's a jump back. But sort of what I wanted to show is that for coral reefs, these critical thresholds are very low. So in fact, we already exceeded them. So last year there was quite a bit of press coverage about the marine heat wave that struck the Great Barrier Reef in Australia, and where there was widespread coral mortality. So so in terms of sort of coral, so we've exceeded that critical threshold already. So if we're talking more about sort of these system level tipping points, so here I'm referring to things like irreversible melting of the West Antarctic ice sheet, which would have several meters of sea level rise, or of the Greenland ice sheet, or things like this disruption of the circulation in the Atlantic Ocean, or setting in motion of the permafrost carbon feedback, which could be caused by melting of permafrost, which then makes a lot of organic material that is stored in these northern soil amenable to decomposition, releasing carbon dioxide and methane into the atmosphere, and potentially getting into this positive feedback loop where you melt permafrost, you release greenhouse gases, this amplifies the warming even further, and then you get into that vicious cycle. So with regard to the ones we sort of likely hit first, according to the current understanding, is the ice sheet ones. So in fact, sort of we may have already exceeded the sort of the tipping point for melting of West Antarctica. Greenland, sort of there's sort of an understanding that it might be around 2 degrees of global warming. So again, so something that we're relatively close to. And with regard to the other ones, the uncertainty is very large. So for for the ocean circulation, I would say we don't know. It's likely sort of higher than 2 degrees, and the same applies to the permafrost carbon sort of feedback or tipping point. So first of all, we still do not we're not sure that it could unleash sort of this this vicious cycle where once set in motion, sort of it could not be stopped anymore. So that's sort of this, it's called a runaway feedback. So I would say the science is not clear about whether that's a possibility. Then sort of the question is, when will large amounts of methane and carbon dioxide be released into the atmosphere? That's also something we sort of, where there's still a very large uncertainty range. So that's something we sort of, we also do some research on in our lab. But because let's say the Arctic is, I mean, it's a huge landscape, and it hasn't been researched very well because it's so difficult to get out there and take measurements and sort of observe the Arctic. So our understanding is still limited. But what climate model simulations seem to suggest is that we could get sort of 50 to perhaps 100 billion tons of carbon that are released from permafrost soil by mid-century. So as climate continues to warm, we'll see an increasing contribution of emissions from those landscapes. But I would say whether this will trigger this sort of runaway feedback that some people talk about. So this is still unclear, and we certainly do not know when this would happen.
Thank you. Daniel, do you want to come in quickly?
Sorry, on the I don't think I have much to add on the physical science front. I think Kirsten's probably better off. Yeah, I'm happy with the answer. Thanks.
So we have about 5 minutes, and I think I'm just I have, I think, 2 questions that I maybe basing myself on the number of comments that I've received. And the first one is on the Canadian context. How do we speak about 1.5 in the Canadian context? Canada, you know, the region of Canada is right next to 3 different oceans. Canada's impact on climate change is feeling, in terms of increase of temperature, in a stronger way than other regions. But at the same time, as a developed country, we have the capacity to respond to these climate impacts in a different way than least developed countries and other countries on the earth. And so how can we put into a context, in the Canadian context, this report and the way to respond to this report? And, you know, the other aspect is, how do we continue to communicate to the public the seriousness of this report? What are your advices and the way we can speak about 1.5 scenarios and how it affects our human and public lives, not only right now because the report was published a couple of weeks ago, but in the future? Maybe Kirsten, do you want to begin?
Daniel, do you want to give it a shot? So because there was sort of an equity dimension here. So
yeah, sure. I think well, yeah, just briefly, I think what Kirsten mentions about what we call the downscaling of climate impacts or temperature change is very important to Canada, because of course we're a big country and climate impacts are going to, of course, affect the country in very profound ways that there's a lot of uncertainty around. So we're not sure what's going to happen, which is more impetus, if anything, in a self-interested way for us to take it seriously. But then, of course, the equity dimension of it, the report, of course, stresses what we already know, that we put off decarbonization so long that the pathways to 1.5 are so steep that the challenge becomes more and more daunting as we put serious mitigation off, and that makes it even more daunting for Canada, as Kirsten said. Of course, there's more of an onus to act on the industrialized world. Historically, we've emitted more. We've also benefited more economically from fossil fueled industrialization. So we're more capable to act. We're a country of very well-educated people relative to most of the world, with a potential for a very diversified economy. And we've chosen to go the way of essentially forming a petrostate, which puts us in a very hard position as a country that wants to, on the international scene, lead, but also is very beholden to fossil fuel interests because so much of our economy is now intertwined with it. So something to do about this, of course, is to use the report to stress the fact that there's essentially no way to sugarcoat the fact that Canada has essentially used up its fair share. And you can quibble about whether we have a bit left or whether we've used it all, but I think the end message for Canada is that we have to decarbonize as quickly as possible. And even at the fastest rate, we're still going to be left with a lot of work to do to help the rest of the world decarbonize. Yeah. And it's our moral imperative to do so, regardless of and the details of that are of course complex and can be discussed for a long time. But I think that's the clearest message that more science these days should send to the public.
Yeah. Kirsten, do you want to maybe give a last word?
Yeah, no. I do agree with Daniel on these points. So I think sort of the other question you posed is how to speak about 1.5, and so again, I think sort of from a positive note. I think I'm sort of showing that it is still possible, that we do have the technological means and also globally also the economic means to respond to this challenge, and sort of to clearly indicate that this sort of the major challenge is political. I think sort of we as concerned citizens really need to take our representatives sort of into or really sort of make it very clear that that this is something which is needed and sort of which we expect from them. So so I think sort of this, I think sort of that's the best, or that's most what we can do as individuals, is actually sort of formulating a very clear message that there needs to be political will to resolve these issues.
Yeah, so I think the main message here that I hear from everyone is inaction isn't acceptable, and science is saying it, but the public is asking for it. So this is actually, Matthew, the message that I think we all want to send, that we have the tools and the means to do better and the possibilities. And so what's lacking is political willingness. So up to us to bring courage to that, and up to you to conclude this webinar, Matthew.
Thank you so much, Eddie, for being with us. Thank you very much, Daniel, as well. And a very special thank you to Kirsten for taking time out of your afternoon there in BC. I would like to draw everyone's attention to the chat feature. The link that I just shared there is an example of how the responses to all of your questions, not just the ones we had time to cover, but we're going to do our best to provide a response, myself, Daniel, and to the extent that she's possible, Kirsten, to help us fill in those responses and have them for you. So I'll be circulating a link to the responses to your questions via email. Thank you very much for being with us. I took note of who we had on the call. We had people from Boston, south of the border. We had people from Nova Scotia, from New Brunswick, and all the way through from every province, with no exceptions. Nobody from PEI or Newfoundland. So we have some work to do, but otherwise we had very good representation. And of course, we need to push north as well and work on some of the territorial issues that come alongside decarbonizing the vast distances north of 60, is it? So thank you all for joining us this evening. Look out for that email with all the responses, and thank you to our panelists and Eddie for moderating.
All right. Have a good night.
Wonderful evening to all. Bye.